Okay, so we're going to review some limits. We're going to start off with this one that says the limit as x goes to 1 of x squared plus 3x minus 5. Now this is a nice polynomial, it's continuous, so the first thing we always try is just direct substitution. So we're going to plug our 1 in for x, so we get 1 squared plus 3 times 1 minus 5. So 1 plus 3 minus 5, we get negative 1. So our limit there would be negative 1. Now, sometimes when we try direct substitution, we get something that's undefined. For example, if we put 3 in here, we would have 0 over 0. So the first thing we can do, we can factor this x squared minus 9. So this is going to be the same as the limit as x goes to 3 of x plus 3, x minus 3 over x minus 3, and we can reduce this, cancel out the x minus 3, and then we can use direct substitution. So we plug the 3 in, and we would have 3 plus 3, or 6. So our limit there would be 6. Now, if we look at the limit as x goes to 5 from the right of 1 over x minus 5, if we just tried to plug this in, we would get 1 over 0, which is undefined, and what's happening is we get an asymptote, a vertical asymptote at 5. So here I've tried to draw a graph of this function, and if we're coming from the right, okay, we see that the limit goes up to infinity. So this limit would be infinity, even though when direct substitution looked like 1 over 0. Sorry, that looked like a negative or something, but it's just equal to infinity. Okay, and then one more we're going to look at. If we have the limit as x goes to infinity of 1 over x squared minus 2. Now, the top here is staying at 1. The bottom here is going toward infinity, right? X squared minus 2 as we go to infinity gets larger and larger and larger. So remember, when the numerator is staying constant with 1 there and the denominator is getting bigger and bigger and bigger, the number is actually going to 0. So that limit would be 0.